Team 83, what school are you with?
University of Buffalo.
University of Buffalo. Cool. And y'all drove out here for the event?
Yeah.
Yeah.
29 hours.
29 hours. Is this the first time you've been here?
Last year was our first year.
Last year was your first year.
Yeah.
All right. Did you fly last year?
We launched. Yeah.
You launched last year, yeah.
Yes.
Did you launch last year? Sorry, no. Did you fly down here?
Yeah, that's what I was. Yeah.
Confusing question, my bad. I'm not like a professional interviewer or anything. I play video games for a living. So you launched last year. Everything go well last year?
Yes.
Have you launched this year?
Yes.
Yes. Well, that's a good thing because this still looks like a rocket.
Yeah. All the pieces are still in one piece.
Yes. So, what happened is flight went great up until the main ejected, and the main parachute itself worked fine, but our Kevlar shock cord got sheared by the fiberglass coupler tube. And this basically free fell from about 1,200 feet.
Yeah.
But it's all together. The fins are all there.
No kidding.
There's some cracks in the fiberglass, but I wouldn't fly it again, but it looks the same.
It's in one piece.
Yeah.
So it free fell from 1,200 feet, you said, because this, you can see the remnants, y'all can't see it from there, don't worry about it, but it sheared off the Kevlar cord.
Yeah.
Quarter-inch thick Kevlar.
What do you think happened?
So as it was spinning, it started cutting through.
Oh.
And then once the main deployed, if you look at the cord, there's just a small piece of it looks like it was left.
Yeah.
Fully broke off.
Yeah.
And it just
the main shock. Just caused
So it was under drogue, I guess?
Yes.
Yeah. And it was sort of falling, but that the Kevlar was sort of like abrading on the edge, like a knife almost.
Right.
And it cut through it, then maybe ripped off when the main came up. But the chutes worked.
Yeah.
The ejection worked.
Yeah, there's
The engine worked. The motor worked.
Yeah.
Nice.
So,
what was your payload? Everybody always asks what the payload was.
oh, where's
the
the
guy already talked to you about
Oh,
that.
hey.
Yeah, that's you.
Yeah, we have everybody here. Like it's the whole.
It's from it, but he's our payload guy.
Yeah.
Okay, cool. Hey, payload guy. What's your name?
Ari.
All right, nice.
Yeah. So what basically Air
all good,
Force
man.
likes to launch CubeSats, which are small satellites that look like this.
Right.
This is our Swiss cheese block, and so when they get launched out, in order to keep track of them, they give them this thing called TLEs, two-line elements. When they launch them, they can launch 10, 20, sometimes even 100 at a time, and these TLEs can get mixed up. So they'll say satellite 1 has TLE 2. So what we get launched is a laser rangefinder, and by combining it with a radio rangefinder and combining it with a multi-model estimator, we can eliminate 98% of these cross TLEs. So that's our payload.
That was the payload. Nice. And you launched with the payload?
Yep, we launched with the payload.
You launched with the payload. And the Swiss cheese part was.
Just a weight.
It's like a weight, so it was the right size and shape and stuff like that.
It's required to launch 8.8 pounds.
Right.
So this circuit board is a little less than that.
A little less than 8.8 pounds.
We launched
I mean, even with the 9-volt battery, it's probably not 8 pounds.
Yeah.
No kidding. Sorry?
Oh yeah, it
bottom
is.
of it?
Oh no, the other ground station one. So
You have to make sure, because engineers aren't the brightest people, it says do not eat on the bottom.
It says do not eat on the bottom?
Yeah.
It literally, can I
Yeah,
it
by
over
all
here?
means.
Let me see if I can get it on the camera. It literally says, we've seen like made on Earth by humans or whatever. This one a little bit less complicated. Does it get focused?
I don't know.
Get the sun on it. Do not eat.
as tasty as it looks.
Did it go?
Can't tell.
Hopefully
so
when we
small
chat,
on the
we'll get it
little
again. If
screen.
it didn't actually show up, I'll show it over there again.
Now, this payload was built by the University of Buffalo Nanosatellite Lab, so if you're a current aerospace engineering or science student at University of Buffalo, or you're about to think of going to college, go on to ubnl.space, so ubnl, the little period, and then SPACE. That's our website. You can apply to work with us. We have hardware that's being delivered to NASA next year and the Air Force hopefully the same year that will be flying in space. This is hardware that, well, this is not the hardware that we'll be flying. This technology
Somebody will
will be
probably
flying.
eat that one.
Yeah, it's tasty. Swiss cheese block.
Yeah.
It's a very snack-related thing.
Yeah.
Dude, you do like a fantastic job. Like, and here's the web address in case you want to apply. Like, I like it.
Here's our Twitter handle and the
here's the
Chiron
Twitter
below.
handle, yeah.
Yeah, no, it was funny actually because when we first watched it, we did not see this fall.
Yeah?
So
Oh,
we were
really?
here, yeah. And then they found this. You guys found this line there. They're like, "Where's the bottom?" And we actually looked on your stream to see if we could find this.
Oh,
falling.
really?
Yeah.
Wait, did y'all see the launch on the stream?
You got, you got.
You have our ascent, but we were like, and you like focused on it.
You got a
after
shot
this
of
was
that
gone.
falling, and there was no booster connected.
There was no booster
Yeah.
connection. We got that on the stream?
Yeah, but we didn't see this
Nice.
fall. So, but yeah, we actually were trying to.
Yeah, even looking with binoculars. Like initially, I saw it with both, so we had no idea when it
Yeah.
started.
Yeah, like the main deployed, we saw them both falling at the same rate, so we
How
got
high
happy
did y'all
and
go?
stopped looking.
8,747.
All right, so
Feet.
almost up to 10K.
Yeah.
It's so hard when it gets up there with the camera to keep the camera focused on
Oh,
it. It's
yeah,
like,
no,
oh
I
my
understand,
god. Sometimes after the shoot pops, it's like, where is it? But what motor did y'all use? Everybody always asks what motor it is.
M3400.
M3400, nice. How tall was it?
9.4 feet.
9.4 feet. How much did it weigh?
That was about 55. With
Oh, with
About
the motor.
55 with everything. All right. So I answered all of your questions, chat, because that's what you always ask. Any other questions? I'm reading what people are asking right now on my phone. I'm not being rude and like
curiosity.
checking it. Sorry, what?
I'm just curious how many you while watching right now.
340 right now.
Where are they from?
Not
Generally
bad.
speaking, you got-
We're chat. Where are you from? Where are you from, chat? Right now. We're also on a 15-second delay, so that'll
Oh,
listen
yeah,
a little bit.
Oh,
Yeah, the backpack is doing the stream and it buffers it. Like it has local memory, so if the cell phone signal is not stable, it keeps going. They got close to the altitude, hey Marvin, because y'all were going for 10 and you made 87, right? There's here, now it's starting to come. New York, UK, DK, Scotland, Michigan, France, California, Buffalo. Somebody's from Buffalo. Nice. Mars, you're hilarious. Netherlands, University of Oklahoma, California, Australia, Canada, Florida, Norway, all right, I can't read them all. Germany, couple Michigans, a San Antonio in there. Yeah, all over the place. North Carolina, yeah, in front of a keyboard. Somebody's always going to say like McMurdo, Antarctica or whatever. Every single time we get Mars and like Antarctica. What is this part of the rocket here? This is a big piece.
Yeah, so this is actually an SRAD flight computer that I designed. It uses a Kalman filter, so it actually has two sensors on here, an accelerometer and a barometer.
Okay.
It also has a basic dynamics model, so it combines those readings with what it knows about the dynamics model in order to more accurately predict apogee.
Nice.
And this actually deployed our charges, and it worked perfectly. It deployed both charges before the COTS flight computer, and we have data logs and everything. It worked just fine. Here we have a camera. I haven't looked at the footage from that
Haven't looked at
yet.
the footage yet? Nice.
No.
I was putting it together because it only had like 2 hours of battery.
Oh yeah. Do you know if you have footage from it?
2 hours of us standing around.
2 hours of you standing around. No flight footage or?
Battery died before we
No,
got it.
we couldn't get the motor in.
Yeah,
quite.
we have a good
We had a lot of.
external
We do have
video
some
of
good launch
takeoff.
photos.
You got some launch
video.
photos? I think the best thing to do when we get those online, we could post up links to them. But right now, it's almost impossible to see on the thing. But we do like streams where we're going to review all the flights and stuff like that. Right. So if you wanted to email me, my website's kerbalispaceacademy.com.
Okay, nice and memorable.
kerbalispaceacademy.com. If you go there, it's got contact information for me, so you could send me pictures or video, whatever you have. So cool. So you made this one, and you also had a commercial off-the-shelf one, right?
Yeah.
Okay.
We got a perfect flight too.
So on the other side, that's called a perfect play.
Perfect flight.
Perfect flight. Sorry, I can't hear. It's hot out here.
The one you made did everything.
Yeah.
So that was like a backup. The commercial thing was a backup.
I think it's
But
required if you have it.
yeah, I think it is required, right?
Yeah.
But everything, like yours worked perfectly. The one that you
Yeah.
made yourself ran the entire rocket. You didn't actually need the backup.
Yeah.
Dude, that's cool. This looks like it's 3D printed. Is that like a 3D printed mount or something for us?
Yeah, it's 3D printed out of PET sheet,
Okay.
and we chose that over PLA because it's a lot higher blast resistance temperature, so it would soften in the 120 degree air pressure.
It was 53 degrees Celsius.
53 degrees Celsius was the temperature of the rocket?
Inside while it was on the pad.
Inside while it was on the pad. No kidding.
Back, well, it's 180 Fahrenheit, which is
we had a
high
big
enough.
margin,
Yeah.
So it survived pretty well. It took a bit of a ding on landing, we think.
Yeah.
But that's a pretty, like...
Oh yeah, one of the supports, but there's multiple supports around it. Dude, that's so fantastic. So right here is what we're pointing at. It cracked right there. Can you see that? Roll it this way a little bit if you can.
Actually.
Yeah, you can see that. Yeah.
It's basically separated.
Yeah, it's separated right there. But there's supports up here. Then it goes through the camera mount. It looks like, and on the other side there's supports as well.
It's all... It's
I like these. These look like they came from Home Depot. Are they like aerospace grade threaded rod? Or
They're from McMaster.
they are. They're from McMaster. Nice. They're aluminum, not steel.
Yeah.
Nice.
Although that made it a bit tricky because they're really flexible, so like mounting this got to be a bit of a...
Oh yeah. And then these are another aluminum pieces that just sort of center everything in the rocket.
Yeah, we were supposed to have a CNC machine to auto cut everything out.
Right.
And then there was a whole kerfuffle with ordering a new one.
A kerfluffle, I like it.
Yeah, because our old one was broken, so these were all had to be hand machined.
Nice.
On like a lathe and stuff.
This was supposed to be pocketed out a bit in order to reduce the weight, but that didn't end up happening.
Ah, gotcha. Are these it looks almost like you started to do it manually or something.
Okay, so this is where the payload sits.
That's where the payload sits.
This bulkhead comes off, it's it comes down in.
Can you pick that up and like show it? Look.
This is
sure.
Yeah, the payload goes in there, and I was seeing the square sort of indentation there.
On each side. In there.
All right, so you sort of screw the end off, you put the payload in, then you.
Yep, this comes off, payload goes in, tightens down on it, and this whole thing slides in here and retained through these screws.
Nice, nice. I saw on the back. Are those charge pans?
Yes, so that's where the black powder is.
So those are little black powder charges right there, and you can see the igniter's like a little squib or something in there to light it, whatever the right term is.
An E-match.
Yeah, an E-match. There you go. And you had 2 black powder charges in there, 2, right?
Yep, there's 2 on this side and 2 on this side.
And 2 on that side.
So
Gotcha.
one side for the main, one side for the drogue, and then one is fired by the student developed.
Right, and the other one's by the COTS one. Nice. Did they both fire?
They both fired.
They both fired. Okay.
So
did they fire at the same time, or?
The COTS flight computer was set to fire the drogue chute 2 seconds after apogee.
Nice.
And it was set to deploy the main parachute 250 feet below where the SRAD one was set.
Right.
So we had a little bit of space like when we could both go off at the same
right.
time.
It was like your chance, or I guess your computer first, and if your computer didn't do it, then the other computer. And it could have even been your computer sent the signal, but then the match failed or something like that, right?
Yeah.
But just the backup is to make sure that it goes.
Yeah, and since they were separated, we can look at the flight logs and we can see that the deployment occurred before the COTS flight computer.
Nice.
triggered it.
No kidding. Cool. What else? Is there anything else we want to talk about the rocket here?
SRAD parachutes, SRAD fiberglass body. So we actually made the parachutes in-house.
Yeah, all this fiberglass
nylon.
Yeah, go for it. Yeah.
So they're the main parachute's actually a 9-foot diameter ripstop nylon. It took
Okay.
about 6 hours to sew in our lab.
You have like a sewing machine.
We have a sewing machine in the lab
parachute?
now. Yeah, so we were sewing it. It took a couple of us, and then the drogue's a little bit smaller that we handmade as well.
Nice.
So those was really fun to make.
It was. They said the main was 9 foot.
9-foot diameter.
9 foot.
It's a big
SRAD. Remember,
parachute.
SRAD is student research and develop, right?
Yes.
Yeah. So anytime they say SRAD, that means they made it. Versus COTS, which is commercial off the shelf.
Yeah.
You go down to Rocket Mart or whatever, and you buy a parachute, right? Yeah. Okay. Cool. You made the fins, you made the body, and everything, right?
Yeah, we manufactured all the fiberglass, the nose cone, the internal structure in here.
Right.
Tail. The one thing that actually is commercial is the fins.
Is the fins? All right.
The material we cut them ourselves.
They're commercial fiberglass. We still
Okay,
cut
you
them
didn't
out.
like
We still
make the
manufacture.
fiberglass, slaved over a hot fiberglass stove all day to make it or whatever.
So it still counts as SRAD because we student designed it.
Yeah, you designed it.
Technically, we just have to design it. We don't have to make it ourselves for it to be SRAD.
Gotcha.
But we did make it all ourselves.
This is actually this is an exact replica of one of the center rings that's inside the bottom structure here.
Okay.
This is student developed fiberglass.
Is that for the motor?
Yes,
So the
that
center
holds
ring for the
motor
engine?
tube. Yeah, the motor tube would go inside.
Yeah. Okay. Cool.
You can give it a try. Try to break inside
You
of
can try
here.
flexing it if you want.
I can try to break it.
Yeah.
Yeah.
It'll break you first, though.
I can try to break this
Hey, you don't have to
apparently.
break it, I'll be impressed.
I mean, I'm not gonna be able to do any. Can I put it on the table and like?
Yeah.
Yep.
I can.
Yeah.
All right. Here,
You
look.
break it, go ahead.
Student research and
We haven't
developed,
tried
right?
that.
Very surprised.
I'm gonna like.
The table's flexible.
I think the table would probably bend first. So y'all made this, and it's a centering ring for the motor, which clearly, because the motor's attached to, or being centered by it, I guess, has to withstand some forces. I mean, the motor has a lot more force than I do, but
I don't know if this light.
Yeah, we're expecting max to run.
So that aluminum ring you see in there is what there's a threaded rod that runs through that that's secured to that, which threads into the motor itself, which holds the motor in from the top. And then there's a ring around the motor on the bottom that sits up against the motor tube, which is just a smaller one of these tubes, which fits inside of that bulkhead
Nice.
right there. That just sort of it sits in there.
I love the testing mechanisms. Yesterday we were up with the team that was getting their final flight check, and the judge was talking about, oh, well, we test the fins to make sure the fins are secure. And I'm like, how do you test it? You have like a calibrated device that like puts a certain amount of pressure. And he's like, no, we go like this. And the guy's sitting there on their rocket going like, hey, yeah, this is how we test it. So I like it. Hey, it's good enough. It works, right? Because you've already tested it other ways, and you know that I'm not going to sit here and break it in half, right? No kidding. So when y'all getting ready to head home?
Tomorrow.
Tomorrow? Driving back up? All right, award ceremony tonight?
Yeah.
All right, good deal. Well, we'll be out there streaming that as well. We're going to take off and get out of your hair, but thank you all so much for the time. I appreciate it. Do y'all want to do your names? Like, go around and do the names right quick so we know who we're talking to? Again, it's University of Buffalo.
Yes, correct.
I always have to remember the order because is it Buffalo University, I don't know. Don't go there. University at Buffalo.
Well, it's the State University.
Okay, it's the State University.
Cuomo.
Do you see why I
You didn't say
asked?
that.
That's why I ask. I don't know. But if you want to just go introduce yourselves one more time.
I'm Ari Rubenstein.
Hey, what'd you do? Or
I
what's your
worked
role
on
if you have
the-
one?
Mostly on the payload and on the common filter for this.
Cool.
I'm Owen Torres. I designed the flight computer.
Nice.
And other avionics stuff.
William Elliott worked on the airframe and the dynamics.
Cool.
I'm Jacob Henry. I'm the airframe lead.
Tom Hill, avionics lead.
Matt Bukowski, I'm the dynamics and recovery lead.
Nick McNally, I did a lot of the airframe work.
I'm Sophia Matlow. I helped with the avionics bay.
And I'm Owen, and I help with propulsion.
Nice. Cool. Thank y'all so much for the time. That's an awesome rocket. Congratulations on your successful launch. Chat, put some love into chat over here for our team that we've just talked to from the State University at Buffalo.
Sounds right.
Something
No,
else.
the
University of Buffalo.
It's a mess.
Just go with University at Buffalo. Go with University at Buffalo. Nice. Good deal. All right, so we're going to move on. Thank y'all so much. Stay out of the sun, drink some water, and we'll see y'all later.